Hello, this is the Significant Figures practice worksheet. This is just an extra set of problems for those students who are still struggling after they did the first set. I'm going to quickly go through them. If you are struggling with significant figures, go back and look at the note set, look at the first worksheet that we did on sig figs, and if after doing that and looking through this worksheet you're still having problems, make sure you come in and talk to me because sig figs are really, really important. So getting started here, this first section is just about counting sig figs. As a reminder, there are only two things that don't count. The two things that don't count are leading zeros, which never count, and trailing zeros when they don't have a decimal point. So leading zeros don't count, trailing zeros with no decimal point don't count. Everything else is significant. So this first one here, none of those are zeros. We just know automatically that those all count. So the number of significant figures in the first one, 5. The second one there, the one below it, we have 1 0 here that we have to think about. That's a sandwich zero. All sandwich zeros count. So that one counts, and so there are 6 in this number. Next one, these are also sandwich zeros. They're between two other non-zero numbers. So those ones count. So this has 4. This one here, this is a leading zero. Leading zeros never count, so we don't count that one. There are only 3 sig figs in here. 1.008, sandwich zeros. All right, so those do count, so there's 4. Next one here, this one's got a couple different kinds of zeros. These are leading. Leading don't count. All right, this one here is a trailing zero. Trailing zero does count in the case that there's a decimal point, and there was a decimal point in this number, so it does count. So that means the 3, the 4, and the 0, that's 3 sig figs. Next one, 2 zeros, these are trailing zeros. There's a decimal point, so the trailing zeros matter. So this one has 6 sig figs. Oh, I miscounted, that's 5. Alrighty, 0.0001. 4 zeros there, those are all leading. They don't count, so this one only has 1 sig fig. Next one here, 700,000. These are trailing zeros, but there's no decimal point on this one, so the trailing zeros don't matter, which means just 1 sig fig. Here, sandwich zero, that one counts. Trailing zero with decimal point, that one counts as well, so there are 6 sig figs here. 1.0000, these are all trailing zeros. There's a decimal point, so they do count, so this has 5. And then lastly here, these 3 are sandwich zeros. Sandwich zeros always count. So there are 6 here. Moving a little further down here, it says we're going to do some calculations here. You got to remember the different rules for calculations with significant figures. The first one is called the addition-subtraction rule. For that one, we have to look at the number of decimal places involved in a number. So for instance, in this first question, the first number goes out to the thousandths place, the second number goes out to the tenths place, the third number goes out to the 10,000ths place. So the least precise of those, the tenths place, is what our number needs to go out to. So you add those all up, and then you round it to the nearest tenth in your calculator, and you should get 169.0. All right, on this next one, again, we're looking at the number of we're looking at the number of decimal places. This one goes out to the hundredths place. This one goes out to the thousandths place. This one goes out to the hundredths place. That means our number needs to be rounded to the nearest hundredth. If you put that into your calculator and round to the nearest hundredth, you should get 582.82. All right, next one. 658 goes out to the ones place. 23.5478 goes out to the 10,000ths place. This one, last number, goes out to the hundredths place. So the least precise there is the ones place. Our answer should be rounded to the nearest 1. So we get 2027 when we're rounding to the nearest 1. Okay, this next section here, we're dealing with the multiplication division rule. So, different rule. Instead of counting decimal places like we counted above, what we're counting is sig figs, and we need to go with the lowest number of sig figs. So this first one here, 23.7, that's 3 sig figs. 3.8, that's 2 sig figs. 2 is the lower number, so we need to have 2 sig figs in our answer. You put it in your calculator and you get 90.06. All right, we need to round this to 2 sig figs. I always say start here on the left, go over until you have 2 sig figs. There's 1 and 2, and then we'd cut it off right here. Okay, it would round to 90, but be careful because we needed to have 2 sig figs. If you write it just like this, 90, that's 1 sig fig. So we need to put a decimal point here to indicate that that last 0 is significant, and then it has 2. So 90 point is actually the correct answer there. For question B, we look at the sig figs again. That is 4 sig figs. This is a leading 0, so it doesn't count. So 0.25 is 2 sig figs. That means we should have 2 sig figs on our answer. We put it in the calculator, we get 11.44. We need to round that to 2 sig figs. So I start over here, 1 and 2. I cut it off here. It's a 4, so I round down. It just rounds down to be 11. For the next set, this number here, that's a sandwich 0, so it counts. So that's 4 sig figs. Here, those leading zeros don't count, but this trailing 0 does count because there's a decimal point. So we have 2 sig figs in the second number. 4 sig figs and 2 sig figs. We have to go with the 2 sig figs in the end. The calculator spits out 0.8104. All right, we need to round it off at 2 sig figs. That 0, that leading 0 isn't 1, so we go through the 8 and the 1, and we round it off here, and that is your final answer. Okay, remember that leading 0 doesn't count as a sig fig, so we don't count it when we're rounding. For problem D, 6.47, that's 3 sig figs. 64.5, that's 3 sig figs. So our answer should have 3 sig figs. You multiply that, you get 417.315. All right, we're going to round it to 3 sig figs. So we go 417 and cut it off there, and we get just 417 in the end. This next one is really interesting. We see that there are 5 sig figs here, and there are 3 here, because none of them are 0, so everything counts. So our answer should have 3. You multiply all this together, you get 2,799.76. All right. However, we need to round this to 3 sig figs. So what we do is we take it, we've got 1, we've got 2, we've got 3, we cut it off here, and it would round up. Now, what it rounds up to, we've got 2,799, rounding to 3 sig figs there. Rounding up, it looks like it rounds to 2,800, right? Okay, but we need 3 sig figs. All right, so rounding it up to 2,800, the problem is that that looks like 2 sig figs. If you put a decimal place here, both of those trailing zeros count, and so then it's 4 sig figs. So you got to remember the special trick if you only want some of the trailing zeros to matter, and it's that little over bar. So we put an over bar on this one and get 2,800. For this next one, that's got 4 sig figs. This 0 is a leading 0, so it doesn't count. So 2 sig figs there on the end. And so what we end up with is 2 sig figs for our answer. If you put it in your calculator, you get 3.99524. We're going to round this at 2 sig figs. So 1, 2, and we're going to cut it off. That's a 9, so we round it up. 3.9 rounded up rounds to 4. But remember, we need to have 2 sig figs, so it ends up being 4.0. For G, the first number here, that's 5 sig figs. We've got 3 there. We should have 3 sig figs in our answer. Out of your calculator, you get 7.58476. We need to round that to 3 sig figs. So we start here, cut it off there at 3 sig figs. That's a 4 after that, so it rounds down. So we end up with just 7.58. And then this last problem, that is 4 sig figs. These are sandwich zeros, so they do count. So this is 4 sig figs as well. All right, 4 sig figs divided by 4 sig figs. We're going to have 4 sig figs in our answer. Put that in the calculator, you get 4252.49. But then we're going to round it to 4 sig figs, so we go through here until we've got 4, we cut it off here. That's a 4, so it's going to round down. So we end up with 4,252. All right, that's it. Again, if you're struggling with this, make sure you come in and ask for help. Thank you.